Hello, Intric City students. I'm Tristan Brown. I'm here with you today to help you with some more math SAT prep. Today we're going to look at another problem from the no calculator section. In fact, in today's video, we're going to look at one of my favorite types of problems, and that's solving systems of equations. It might sound odd, but I've always really enjoyed this type of problem more than others in math. Obviously, I know that's a little odd to say I would enjoy math, but especially a specific part of it. But I've always really liked these types of problems, so I'm excited to go through this. This problem comes from the heart of algebra section. As you can tell, we're yellow today, so this is what would be considered an intermediate difficulty problem. So let's look at the problem and then we'll go through it. Remember, this is a video. If at any point you want to pause it before I get to solving it to see if you can do it without any aid, or if you need to rewind it to go back and look at a step or something that may have seemed odd, or like I might have done something that you weren't expecting. Obviously, you can go back, rewind it, do whatever you need to make sure you understand this problem completely. Any type of problem like this is possible to be on your SAT. A problem like this could very much so be on either section of the SAT. Just in this case, we can't, since it is on the no calculator section, we just can't use a calculator. So that being said, let's get to our problem. So it gives us the system of equations. It says 4x minus y equals 3y plus 7, and x plus 8y equals 4. It says, based on the system of equations above, what is the value of the product of x, y? All right, so we've got a couple things here. One, we have the system of equations. And then it says, using that system of equation, what's the product? Product infers and implies multiplication. And then it gives us this xy, which is just x times y. So just think about this problem for a second before I go into it. We have these, and we want to find what x times y is. So I want you to think about how we might get that. So if you need time, you can pause the video right here. If not, I'm going to give you just a couple seconds, and then we're going to delve into this problem. So I'm very excited to get to do. All right, so hopefully you've thought about it at least a little bit by now and have some semblance of an idea of what we're going to do. So the second equation, the x plus 8y equals 4, that's something we're accustomed to seeing. That looks fine, especially for solving a system of equations. However, this one, the 4x minus y equals 3y plus 7, isn't quite the way we would like it. So our first step, or at least what my first step is going to be, is to solve it for a way that it looks nice and it's easy to solve. So we have, or it's easy to deal with. We won't be solving the equation necessarily. It's a system. You can't solve one equation. When you have a system, you have to solve them all. So we have 4x minus y equals 3y plus 7. So we have these two y terms, and we can subtract or add anything from one side to the other as long as we do it to both sides. So all I'm going to do is subtract this 3y over to this side. So subtracting 3y from positive 3y gives us 0. And subtracting 3y from negative y is going to give us negative 4y. And then everything else just comes down the way it was. It's unaffected. So then we have 4x minus 4y equals 7. And now it's in the same form as this. Now if I rewrite this whole system of equations, we get x plus 8y equals 4. And then now we have this equation. I actually wrote that backwards. It's not causing any confusion. Let me write that the way that it's presented here. So I'll write this one first. Now we have our new version of that first equation, 4x minus 4y equals 7, which is the way we want it to look. So that's good. And then we're just going to bring over the second equation because it's already in a nice form. X plus 8y equals 4. Hopefully at this point you have some idea of what to do. Remember, when we're solving for a system of equations, we want to find what the value of x and the value of y is. If this was on the no calculator section, what you could do is just set both of these equations equal to y, graph them, and find the point where they intersect, and that would be your solution for the first half of this problem. However, we don't have access to a calculator on this section, so what we have to do is actually do the algebra to solve for these instead of just being able to graph the functions. So to do that, what we have to do is eliminate either our x or our y. Then we'll solve for the other value or variable. And then once we have that, we'll plug it back into one of the equations and solve it through and get the value for the other variable. What I see is that this -4 and this +8, they have a really nice relation, because -4 times 2 gives me -8, and -8 plus +8 is 0, which is what we like. So to get that, like I said, we have to multiply this by 2. So I'm going to multiply this entire equation by 2. Remember if you're going to do it to one side, you have to do it to all sides. So we're going to multiply that by 2, and I'm going to bring my solution down. So 2 times 4x gives me 8x. 2 times -4y gives me -8y. 2 times 7 equals 14. There it goes. All right, and then the second equation we didn't change, so we're just going to bring it down. And we're just going to have our x plus 8y equals 4. Now at this point, like I said, we want to rid ourselves of one of these variables. And now that our y's are opposite values, what we're going to do is we're just going to add these two equations together. And then it's just basic addition. 8x plus x, which is 1x, is 9x. -8y plus +8y is just 0. So I'm not even going to bring that down. I'll just leave an empty space there to show that it cancels out. And then 14 plus 4 is 18. So then we just solve this like we would any normal equation, and we just divide by 9, and we get x equals 2, because 18 divided by 9 is 2. So now that we have x, what we do is we take x and we put it to either this equation or this equation to figure out what the y value is. Since there's no coefficient in front of x on the second equation, I'm just going to use that. So I'm going to plug in 2 for x plus 8y equals 4. So now we have this. I'm going to subtract both sides by 2, and then I'm going to be left with 8y equals, subtract 2, gives us 2. So y equals 1/4. And then just to check to make sure these are both right, which I highly recommend you do, is we plug them both into this other equation, 4x minus 4y equals 7. And if when we plug both of these in, we get 7 as our end result, it means we did it right. So it's just a way to check yourself. Anytime we can check ourselves in math, I always find it's a good thing to do. So we're going to plug in 2 for x. So we have 4 times 2 minus 4. And I'm just bringing that down from the equation. And then that's going to be times 1/4 for the y equals 7. So then we're going to multiply that out, make sure it's all right. I don't want to go too far, so it has to give the answer away. So then 4 times 2 is 8, and 4 times 1/4 is just 1, and there's a minus sign in front of it, so it's -1. It says that equals 7, and at that point, 8 minus 1 is 7, and 7 equals 7. So that means we did get the right answers with x equals 2 and y equals 1/4. Again, this part right here was just to check ourselves to make sure those were right. You didn't have to do that. I just highly suggest you do it because it guarantees you have the right answers. All right, so now that we have that, however, we're not trying to look for the solution set. Like I said, the SAT, sometimes they give you that extra step to do. And in this case, now that we have x and y, it wants us to find the product of them multiplied together. So all we're going to do, xy equals 2 times 1/4. Yeah, y equals 1/4, which just equals 1/2. So that should mean, in theory, that C is our correct answer. So now if I scroll down to the next slide, let's see what it says. And C as 1/2 was the correct answer, which means 1/2 was x times y, which means we did the problem right. And like typical, the y's, well, we had to rewrite the first equation in this form, that ax plus by equals c. Just for reference, because sometimes I do know it can be confusing when we generalize formulas or equations in math, because we don't really, or most teachers don't typically explain what it means. This A and this B, yes, we're representing them by letters, but that just means that A is representative of any possible rational or any possible real number, and the same for B is represented by any possible real number, and C is what would typically be considered a constant, but it's also just any real number, which is negative infinity to positive infinity. And then x and y, of course, were our two variables, and those are also interchangeable. You could have had z as one of them, or a and b. It can be confusing, but what this means is that we have a is the coefficient of the first variable, b is the coefficient, which is just, again, some sort of real number. That's the coefficient of the second variable, and c is what they're equal to in that format. So I just thought I'd clarify that. For any time I want to generalize something like that, that's all it means. I know letters, when we put too many letters, obviously there's no numbers in this generalized formula, but that's just so we know that it could equal any number. And then, like I said, we had to solve for either x or y. And there were a number of ways you could have done that. You could have solved one of the equations and said one either equal to y equals something or x equals something, and plugged it into the other equation. I've never been a fan of using that way. I know some of you might be better using substitution than you would be using elimination like I did in this video, and that's fine, and you're welcome to do that. Whatever works best for you, obviously, is what I want you to do is to succeed on the SAT. And then again, once we found the one value, you'd still have plugged it into the other equation to find the value for the second variable. And then once you had the two of them, which was the 2 and the 1/4, you just had to multiply together to get that last step, which the SAT wanted. And then my tip, even though I did it while we were working out the problem, once you have those solutions, plug them into both equations, make sure they work out so that you're certain that you have the right answers. Obviously, if you do the algebra right, once you solve it, once you plug your x or your y into one equation to find the other variable, that's obviously going to work for that equation if your algebra is right. But if you don't plug into the second equation, it might not necessarily be the most correct. Well, it wouldn't be the correct answer if it doesn't work for both. And you can do that because they're obviously not the same line. If they were the same line, you would have infinitely many solutions, and I don't think they'd give you anything like that, at least not on the no calculator section. So that being said, I thank you guys for watching. I hope this was helpful. Remember, you go back and watch this as many times as you need to. Even though, like I said at the very beginning, this is one of my favorite types of problems, and I love doing this. It might not be that way for most of you, and I understand that. So just watch this video as much as you need to so that you fully understand how to do this type of problem. Thank you for watching, and I will see you guys in the next video.